Hello everyone and welcome back to our videos. In the last video we talked about the overhaul of turbine engine and we start with the two procedures or with the first procedures of overhaul, the disassembly and the second one the cleaning. And we mentioned how to make cleaning and which solvent it will be used. And we talked about the visual inspection, but not for every part of the engine. We talked in generally, and we said the visual inspection we will make for some defects like blending, blistering, bow, plug, compression, creep, and also the flowing, glazing, growth, guttering, profile, shear, and the last one, tension. Today we will talk about the first one, compression or the compressor section, and what the most thing that will defect or the things that we will see it in the compression on the compressor while visual inspection. The fan or first stage compressor blade are vulnerable to damage caused by ingesting of FOD, foreign object damage, and also erosion. Compressor blade and vane must be visual inspection from crack, dent, gouges, and other defect caused by FOD, foreign object damage. It's very important that you be able to detect and correct blades defects because a single blade failure can lead to total engine damage. In this figure we will see some defect of compressor blade. The first one, dent, jarring, score, corrosion, and the type of corrosion is the pitting, cracks, damage repair like blend, burn, gouges, and scratches. Light or minor FOD damage can be repaired by blending that affected area away and then countering to final shape. Any damage in the root of the blade requires blade replacement. The erosion of a blade and vane result from dirt, sand, dust, and other fine airborne contaminant. To increase compressor efficiency, the clearance between the compressor blade and the compressor casing must be as small as possible. A blade's erosion is accumulative and occurs over many hours of operation. Erosion shows up as a loss of material on the blade leading edge and near the blade root. So you have to focus on making overhaul of the blades of the compressor. The erosion it will shows on the leading or near the blade. Visual inspection of combustion chamber. The acceptable crack in the combustion is vary from the engine models. You must follow the maintenance manual when inspection the combustion chamber. Some of the defects found during inspection: crack, burner can shaft, hot spot or scratched area, warping, and erosion. Combustion liner should be checked for excess weld. Crack in the cone or swirl vane are caused to rejection the combustion liner. Fuel nozzle can damage the combustion liner. The result, hot spots or scratch area in the liner result from contact due to malfunction or misaligned fuel nozzle, for example partially closing or closed cause hot streaking, burn marks along the length of combustion that result from unatomized fuel contacting the combustion liner and then burning pass through the turbine till visual inspection of turbine section. The turbine subjected to a great of heat and stress because it's after the combustion chamber. The common defect found is cracking and erosion. Turbine nozzle vane. The hottest gas in turbine passes through the first set of turbine nozzle vane. Small amount of cracking may be acceptable. Converging crack component must be replaced to prevent engine damage. High-speed hot gases cause a set of vane bowing and warping. How bowing is measured? The bowing measured by the trailing edge using a flat fixture. Here we have the blade and here we have a fixed fixture. The method to check the vane for bowing is accomplished by placing the vane on a flat plate fixture and inserting thickness gauge under the leading and trailing edge. We will take the thickness gauge and insert it between the fixed fixture and the blade. Turbine disc visual inspection. 2. Or it inspect using strong light or magnifying glass. Any crack found in turbine disc, cause, reject and replaced. Turbine blade inspection. Crack is not permitted in turbine blade. So if there is a crack on the blade, you have to reject and replace with another one. Stress rupture crack. This is the most common type of damage found in turbine blades, fine hair line crack that appear at right angle to the blade length, caused by excessive temperature or centrifugal loading. Turbine blades are more prone to creep than compressor blade due to high temperature or centrifugal loading imposed during engine cycle. What's the meaning of engine cycle? Engine cycle consists of engine start, operation for a period of time, and shutdown. Blade creep classification. We have three classifications of the blade creep. The first one, primary creep, occurs during an engine first run when a new blade experiences operational stresses for the first time. The secondary creep occurs during many hours of operation. The last one, tertiary creep, occurs at an accelerated rate after a period of the second creep. When remove turbine blade to inspection, it must be reinstalled in the same slot to maintain turbine wheel balance. Visual inspection of the exhaust section. Exhaust section subject to the same high stresses and corrosive environment as the turbine section. Warping, buckling, and cracking are the most defects found in the exhaust section during inspection. Malfunction of fuel nozzle or combustion chamber produce hot spot or hot spot streaking on the exhaust cone and tailpipe. The combustion in the tailpipe, if the secondary air doesn't properly control the flame zone, the flame may be allowed to contact the exhaust cone or tailpipe and causing warping in the exhaust tailpipe. During overhaul, if you make a visual inspection and you found that you have a damage or crack or burned area in one of the turbine engine components, you have to make a marking for these parts. The marking parts that you must use, we will tell you about it now. The area to be repaired on a cold and hot section needed to mark during inspection. So, the approved marking material for both cold and hot section included the following: chalk, the first one. The second one, layout dye. Layout dye, danger when used in hot section if it isn't removed completely. The third one, fill tip applicator and marking pencil. The use of either wax or grease marking pencil acceptable for parts that are not directly exposed to extreme heat. Never use a common graphite lead pencil or any marker that leaves a carbon, zinc, copper, or lead deposit, because these deposits can be drawn into the metal when heated, causing anti-gloral stresses. Structural inspection. You will make visual inspection for the structure of the engine, and you will use another method of inspection. The structural inspections are conducted using the method of non-destructive testing, such as magnetic particle inspection. This can only be used on ferrous material. The second one, dye penetrant inspection. The third one, ED current inspection. The fourth one, radiography inspection. The fifth one, ultrasonic inspection. And the last one, visual inspection. And you studied these inspections on the General Book Chapter 11. The purpose of structure inspection. It used to detect hidden flaws that are undetectable through visual inspection. The last inspection you will make it for the engine during overhaul, the dimensional inspection. It's very important to check the tolerance and fits for the engine parts during overhaul. Special tool provided from the engine manufacturer must be used to obtain accurate reading. A thickness gauge is used to check the clearances between turbine blades and the shroud unless a special tool is required by the manufacturer.